We want to tackle this head on, and I'd love for you to go through a few of the possible dating methods. But before we do that, can you tackle a question from one of our viewers?
Sure, love to.
All right, let's take a look.
So, I have a question. What would you say would be the best scientific evidence that points to a young Earth and that sort of shows the flaws in an old Earth theory?
It's an interesting question. How you address that?
So I actually, I think the question may have been better phrased to say, what's the best scientific evidence for an old Earth? Because almost all the evidence we see is for a young Earth. And so, to me, it actually, this radiometric dating, if I make atheistic assumptions, would be the best evidence for an old Earth. In other words, if I assume these decay rates have been constant, I assume but all the other evidence that we see would favor a young Earth. And many people have made many lists. There's close to 100 ways of dating the Earth, all end up being with a young Earth. I'll give the top 10. People talk about just the amount of sediment on the seafloor. And we can measure how fast sediment goes in. We measure how fast sediment goes out. Limits the age of the Earth to much, much younger than the current 4.54 billion years. Bent rock layers. You have these rock layers, and I know you've been to the bottom of the Grand Canyon.
Yes.
You're down there, and they make S curves.
So smoothly.
And it's bent, and you take that rock, and it'll just crumble between your fingers. There's no cracks in those rocks. It's a smooth bend, and so any people say, well, maybe rocks lifted up, others sunk down. Well, there's no cracking, which would have obviously happened if that had occurred. There's
it had to be still soft.
Yeah, it had to be soft. It had to almost be laid down. Yeah, and that
laid down rapidly.
Right, laid down rapidly. And it's again, it's the continuous layer. We find soft tissue in fossils. I mean, it's hard to imagine how soft tissue even survived since the flood, but it apparently did, because we do find soft tissue in dinosaur bones and elsewhere.
But certainly not
millions of years. Exactly. The strength of the Earth's magnetic field, the total energy, we can measure that. It's decaying rapidly, very consistent with a young Earth, completely inconsistent with a Earth that's billions of years old. The mechanisms for trying to create the magnetic field that would let it survive that long,
like dynamos that recharge and all of this.
It's very, very contrived. Very, very, the odds of that happening. And then now we're finding magnetic fields throughout the solar system. And so again, it's just like you're taking almost impossible and then squaring it or cubing it or taking it to the fourth power. Now, helium in radioactive rocks, and that's one we can talk about. When uranium decays to lead, so you take uranium-238 decaying to lead-206, you actually produce 8 helium nuclei. And so say I take a zircon, and zircons do make the news about maybe once a year, or how into it someone is. If I look at a zircon and I assume that it was all uranium when that zircon first formed, and then I measure the uranium and the lead ratio inside that zircon, well, I can get an estimate for the age, but I have to know what the half-life was through that whole period of time. So that's one estimate. Well, if I assume the current half-life for uranium, that I get very old ages, like you said, billions of years. But I can also measure how much helium is left in that zircon. And so I can look and say, well, how much helium, and I can measure how fast helium diffuses out of zircons, so I can use that as a method also of dating. It'd be like if we came in here and there was a helium balloon up in the ceiling, and someone said, well, that helium balloon, boy, it's here when we first built the building, and it's just stuck up there since. You're like, man, that's a really good balloon, or they got it wrong. Because most, you realize just average helium balloon, it's, a few days it's down on the floor.
Give it a week and it's on the floor.
Exactly. And so, so the same thing. We look at those zircons, and if they were really that old, we would expect that helium to be gone, or almost gone. Very small fraction to be remaining in that zircon, but most of the helium's still there.
Still there.
Objective, again, without trying to. Just pure science, not trying to be an atheist, not trying to be a Christian, just pure science. I look at that objectively and I say, a lot of uranium turned into lead and had to happen recently. And that would be the objective conclusion. It's not but if I put the religion on it, if I'm an atheist and I say, well, no, but my religion says that it had to be billions of years old. Well, then you're ignoring important data.
You ignore the evidence. You ignore the data. So
and you just say, well, must have stayed in there somehow. Well, that's not science.
No. So you develop this rescuing device to try to get the helium to stay in there or somehow generate. over billions of years.
Or it's like the soft tissue in dinosaur bones.
That we could
They say, well, we don't know how it lasted 65 million years, but we know it must have. Well, no, you don't. You know, you have to.
But we're getting two different results here. You can measure the exact same rocks, right? And you can get one measurement with atheistic assumptions from the radiometric dating. You measure the helium and you get 6,000 years.
Right. Yeah.
Right? So two different measurements. Which one do we trust? Which one are too many interpretations being placed on?
Yeah, exactly. To me, again, it's the real science versus fake science.
Okay.
And we see a lot of fake science in this area when people pretend that maybe life made itself, or they invoke, and this is another one. If I'm ignoring data, that's not real science. I mean, that's, I can look at, say I have a rock and there's different ways of measuring, say different isotope chains, different decay chains that I can use to try to measure the age of that rock. A lot of times I get completely different dates. In other words, dates that are more than 1 or 2 standard deviations different from each other. Well, scientifically, that's a huge clue. In other words, if maybe all the dates say that rock's more than 1 billion years old, but if one is saying it's 1.2 billion years old, another is saying it's 2-point-something billion years old, another saying it's 1.6 billion years old, I actually don't know how old that rock is.
Doesn't that mean that at least 2 are wrong, and maybe all
possibly 3? Yeah.
Okay.
Yeah. If I said my coffee cup, say I sent it off to a lab and they were measuring, okay, how tall is my coffee cup? Okay. And one lab came back and said, well, it's 1 mile tall. And another lab came back and said, no, it's 2 miles tall. Another came back and said it's 3 miles tall. But it was like, say you got 1 mile plus or minus a yard, 2 miles plus or minus 2 yards, 3 miles plus or minus 3 yards. Well, I could come back and say, I don't know how big it is, but I know it's at least 1 mile tall because that's the shortest.
That's the plus. You're using the lowest error bars possible.
And that's how it's often portrayed to the public, portrayed to people. But the reality is, what I can really do is I look at that data and I say, wait a second, none of those, that's not consistent. None of those measurements are consistent. So therefore, at least 2 are wrong, just like you said. Right. There's a really good chance all 3 are wrong. And of course, in that case, all 3 would be wrong.
Now, I love going out on the street and asking people on the street questions because you get a good gauge of what people are thinking. We went out and we asked people, how do you think scientists find out how old a fossil is? This is what we got.
Great.
Carbon dating? I think that's right. That sounds super smart.
I think it's mostly the carbon dating.
It's a special device they use. I don't know the terminology of that device, but it's a device they use.
I guess through carbon dating, yes.
Hire the right man who knows what he's talking about.
Carbon dating, that's what people our age do, carbon date.
They were used carbon dating back when I was in school. I think that might be one of the methods they still use.
How old a fossil is? I think they do a carbon dating on it.
Look at my birth certificate.
I don't know, but I know it's something scientific with maybe carbon dating, I think is the term.
Well, the popular method is carbon dating.
There you go, carbon dating, yeah. It had a name, I just didn't know it.
Well, I know they use carbon-14 dating, and there again, I don't know how accurate it is.
So carbon dating, C14 dating, actually affirms, based just on a literal interpretation, on an extrapolation of the data, that if you find any measurable amounts of C14 in a sample, it's, say, less than 100,000 years old.
Right. Yeah,
much less.
Because half of the carbon-14 goes away every 5,730 years. And so if you think, if you do half, then a fourth, and an eighth, and a 16th, keep going, you figure out that, within, even if the entire Earth was made of carbon-14 to start with, it would all have decayed away in well under 1 million years. And
We've only got 30 seconds, but I want you to drive this home. Tell me about C14 in diamonds.
So we find carbon-14 in diamonds, we find carbon-14 in coal, we find carbon-14 in all these places that it should have long since decayed away, which is, again, very powerful evidence that there's something wrong with the assumptions we put into radiometric dating.
Finding observable amounts of C14 in diamonds, supposed to be some of the oldest rocks, billions of years old, would indicate that the assumptions placed on these dating methods are incorrect, and that we need to rethink these things. From a biblical perspective, everything makes sense. The flood explains so much about what we see around us in the universe today, and also all of the facts of life.